Have you ever wondered how computers understand numbers? Welcome to the world of hexadecimal numbers, a base 16 number system that is widely used in computing and digital electronics. Each digit in this system represents 4 binary digits, also known as bits, making it a convenient way to express binary coded values. Now you might be wondering, how does it do that? Well, hexadecimal numbers use the digits 0 to 9 and the letters A to F to represent values from 0 to 15. This unique feature makes them incredibly efficient and versatile in the realm of digital technology. From representing memory addresses in programming to dictating RGB color values in web development, hexadecimal numbers play a pivotal role. So, if you're ready to delve into this fascinating world where digits and letters mingle to create a powerful coding language, join us as we unravel the mysteries of hexadecimal numbers. So, let's dive into the world of hexadecimal numbers and find out how they work. Hexadecimal numbers are interesting, aren't they? They have 16 digits. Now let's delve deeper into the representation of these numbers. Hexadecimal system, also known as base 16, employs a set of 16 distinct symbols to represent values. The first 10 are the regular numerals from 0 to 9, but here's where it gets a bit spicy. The remaining 6 symbols are the letters A through F. These letters are not just for show, they represent the decimal values 10 through 15. Now you might be wondering, how do we arrange these symbols to represent numbers? Well, just like decimal and binary systems, hexadecimal uses positional notation. Each position in a hexadecimal number represents a power of 16. As we move left from the decimal point, the power increases, and as we move right, it decreases. For example, the number 2A3 in hexadecimal represents 2 times 16 squared, plus 10 times 16 to the first power, plus 3 times 16 to the 0 power. This is equivalent to 563 in decimal. But there's more to the hexadecimal system than just a different set of symbols. Each hexadecimal digit corresponds to a 4-bit binary value. This correlation makes hexadecimal numbers a convenient way to express binary coded values. For instance, the hexadecimal digit A stands for the binary value 1010. This relationship between hexadecimal and binary is particularly useful in the world of computing and digital electronics. It allows for a more compact representation of binary data, which can be quite lengthy and difficult to read. So, in a nutshell, hexadecimal numbers use 16 symbols, 0 to 9 and A to F, to represent values. The position of each symbol determines its value, similar to how it works in decimal and binary systems. Each hexadecimal digit corresponds to a 4-bit binary value, making it a practical way to express binary data. Now that we understand how hexadecimal numbers are represented, let's see how to convert them. Conversion between number systems is a common task in computing. Let's start with converting decimal to hexadecimal. Imagine you have a decimal number, let's say 255. Divide this number by 16, the base of the hexadecimal system, and note the remainder. Continue this process until you reach 0. The hexadecimal equivalent is obtained by reading these remainders from bottom to top, which in this case would be FF. Now, from hexadecimal to decimal, multiply each hexadecimal digit by 16 raised to the power of its position from right to left, starting from 0. For example, consider the hexadecimal number 1A. The decimal equivalent is calculated as 1 multiplied by 16 raised to the power of 1 plus 10. Remember, A represents 10, multiplied by 16 raised to the power of 0, which equals 26. Next up, binary to hexadecimal conversion. Group the binary digits into sets of 4, starting from the right. Convert each group to its hexadecimal equivalent. For instance, if you have the binary number 1101101101011, divide it into 3 groups, 1101, 1010, and 1011. The corresponding hexadecimal digits are D, A, and B. So the hexadecimal equivalent is DAB. Lastly, to convert hexadecimal to binary, simply convert each hexadecimal digit to its 4-bit binary equivalent. If you have the hexadecimal number 1F, the binary equivalent is 0001 for 1 and 1111 for F. Thus, the binary representation is 00011111. Remember, the key to mastering these conversions lies in practice. The hexadecimal system might seem a bit tricky at first, especially with its use of both numbers and letters. But once you get the hang of it, you'll find it's a rather efficient way to express binary coded values, especially in the realm of computing and digital electronics. With these conversion techniques, you can now easily switch between decimal, binary, and hexadecimal. Hexadecimal numbers are not just a mathematical concept, they have practical applications in programming too. They're actually our trusty sidekicks in the world of coding, helping us to express binary-coded values in a much more compact way. Let's take a closer look at how they do this. You see, each hexadecimal digit corresponds to a 4-bit binary value. That means you can represent a long string of binary code with just a few hexadecimal digits. For example, the binary value 11010011 can be elegantly represented as D3 in hexadecimal. This is particularly useful in assembly language programming where binary values need to be manipulated and read frequently. But the magic of hexadecimal numbers doesn't stop there. They also play a starring role in representing memory addresses in programming. In fact, if you've ever debugged a program, you've probably come across hexadecimal numbers representing memory addresses. Using hexadecimal makes these addresses easier to read and write, a boon for programmers dealing with low-level details. Now let's switch gears a bit and talk about colors. Yes, you heard that right. Colors. Hexadecimal numbers are used to represent RGB color values in web development. Each color is represented by a 6-digit hexadecimal number, with the first 2 digits representing red, the next 2 green, and the last 2 blue. For instance, pure red is represented as FF0000, while pure green is 00FF00, and pure blue is 0000FF. So as you can see, hexadecimal numbers are incredibly versatile. They help us deal with binary values, memory addresses, and even colors in a much more efficient and compact way. They're one of those behind-the-scenes heroes, quietly making the lives of programmers that much easier. So hexadecimal numbers are pretty handy in the world of programming, aren't they? Whether you're dabbling in low-level programming, debugging, or designing a vibrant website, these base 16 numbers are there to lend a helping hand. Let's solidify our understanding of hexadecimal numbers with some examples. Imagine a world where hexadecimal numbers are the norm. In this world, counting from 0 to 15 would look like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Yes, you heard that right. A through F are considered numbers in this world. Converting between number systems is a common task in computing. Let's say you have the hexadecimal number 1A3, and you want to convert it to binary. You would start by converting each digit separately. The digit 1 in binary is 0001, A corresponds to 1010, and 3 translates to 0011. Put them together, and you get the binary number 000110100011. Now, let's take the decimal number 412. To convert it to hexadecimal, you would repeatedly divide by 16, noting down the remainders. The process would look something like this. 412 divided by 16 equals 25, remainder 12. 12 in hexadecimal is C. Then 25 divided by 16 equals 1, remainder 9. Put it all together and you get 192, or 19C in hexadecimal. Hexadecimal addition is another nifty application. Let's add A5 and 3F. Starting from the right, 5 plus F equals 14, or E in hexadecimal. Then A plus 3 equals 13, or D. However, since we're dealing with hexadecimal numbers, we carry 1 to the next column. So A plus 3 plus 1 equals 14, or E. Thus, a 5 plus 3F equals E4. These examples should help you get a better grasp of how hexadecimal numbers work. With a little practice, you'll be able to convert between number systems and perform hexadecimal operations with ease. Just remember, when it comes to hexadecimal numbers, A through F are your friends. So, we've covered quite a bit about hexadecimal numbers. They're a versatile base 16 system where each digit represents 4 bits, making it a handy way to express binary coded values. We learned that hexadecimal uses 16 digits from 0 to 9 and A to F, with the letters standing in for decimal values 10 through 15. We delved into how to convert between decimal, binary, and hexadecimal using simple division, multiplication, and grouping techniques. We also saw how hexadecimal numbers are used in programming, from representing memory addresses to defining RGB color values in web development. We even took a look at some examples, showing how to convert between different number systems and even perform hexadecimal addition. Remember, hexadecimal numbers are not just a part of low-level programming, they're a part of the foundation that makes our digital world work. With this knowledge, you're now better equipped to understand the numerical world of computers. Until next time, Happy computing!